So this question is a little bit tricky to read, but let's look at it together. It says that we have 4 situations for which we have a source and a detector. And the source has a variable frequency that it can emit at. So it's a speaker that changes its frequency. However, the detector that we are going to, when we look at the detector, we're going to look at the same frequency. So we observe the same frequency. We want to rank each situation according to the frequency of the source from lowest to greatest. And in each of the 4 situations, the sources and the detectors can be moving or not moving, depending on what's happening. So I know that the observed force, or observed frequency, let me get the right variable here, is equal to the velocity of the sound itself plus the velocity of the observer divided by the velocity of sound minus the velocity of the source. And this is all times the frequency of the source. So my observer is my detector. My source is my S. So if I rearrange this equation, I want to figure out what the frequency of the source is. So frequency of the source is equal to velocity of sound minus the velocity of the source over the velocity of sound plus the velocity of the detector, all times the frequency that we observe at the detector. And I know that this equation, sometimes you see it in a different form where it has pluses and minuses, or plus minus and a minus plus. But I remember that if the detector and the source are moving towards each other, then these each get plus signs. If they're moving away from each other, then we introduce another minus sign into these. So in this case, the source and the detector are moving towards each other. So I have velocity minus a positive value, so this is a shorter value, divided by the velocity times, or plus a large value, so that's going to be a larger value. So this case 4 is going to be my smallest. I'm dividing by I have a small number divided by a large number. If I look at case 1 is where I have, they're moving away from each other, so it's the velocity minus the source, but the source has another minus sign. So this is going to be velocity minus a minus source over a velocity plus a minus detector, because the detector is moving away from the source. And this is going to give us the frequency that our source would have to produce. So this is a large number, V plus VF, or VS, divided by V minus VD. So a large number divided by a small number. So this is going to be my largest. So let's see if I've eliminated some choices out. I know that 4 is my smallest, my lowest frequency, so 4 has to be in the first spot. And now I have to check to see if, what are the cases in the middle. So 4 is my smallest frequency. 3, let's see if 3 is smaller than 2. Well, 2, if they're moving at the same speed, in the same direction, then one of them will get a positive sign. This will have a positive sign. This one will have a negative sign. And what will happen is we'll get the same value. We're going to actually get the same frequency for this. So this frequency is the original frequency. This is higher than it. This is a lower produced frequency. However, the source, if the source is moving towards the detector, we have V minus Vs over V plus Vd times our original source, original detector, our detector reading. Well, Vs is a positive value, and Vd gets eliminated for case 3. So in case 3, we have a small number dividing by a medium number. Over here, we had a small number dividing by a large number. Small number divided by a large number, a small number divided by a medium number, and a number divided by itself. So if you actually think about this one will be the smallest, this will be the second smallest, this will be the third smallest, and this will be the largest. So it's just a matter of getting the minus signs the right way and realizing that we're looking at the detector reading being the same reading. A little bit of a confusing problem, but just plugging in the values, figuring out what numbers are large, which numbers are smaller. You could always plug in numbers to figure this one out, but you can think about this if you just take a moment to think what's larger than other values.